So today we're going to start chapter 8, and we're going to go over classifying the different types of polynomials by both degree and also by the number of terms, and then we will go over adding and subtracting them. So there's a lot of important vocabulary that we're going to go over. So the first thing we're going to talk about here is an expression which the sum of terms of the form ax to the k power, where k is a non-negative integer, is a polynomial. So for example, a polynomial might look something like this. It might say like ax to the 5th power plus some x to the 3rd power minus x squared plus 3 or something like that. So it's going to start with some x to some power, and then it's going to continue on adding or subtracting any terms with exponents that are lower than the original one. Polynomials are usually written in standard form. This means that the terms are placed in descending order from the largest exponent to the smallest exponent. And the degree of each term of a polynomial is the degree of the exponent of that variable. The degree of the polynomial is the largest degree of all of the terms. And the lead coefficient is the coefficient of the first term when it's in standard form. So just to talk about that standard form for a minute, for example, standard form right here, standard form would look something like this. So if I were to put this one in standard form here, just to kind of give you an idea, we would have ax, let's say, cubed plus bx squared plus cx plus our constant, which would maybe be a d in that situation. So notice that the x terms are going in descending order. So we have the largest exponent first, then we would go down in decreasing order. So x squared, then followed by the x, then followed by the constant. Now, the numbers in front of these x's, these are the coefficients, and the lead coefficient would be the one in front of the x with the largest variable, or with the largest exponent, I'm sorry. So classifying polynomials, so we classify them two ways. One is by degree and one is by number of terms. So when we go to classify them by degree, a degree of 0 is called a constant term. And really what we're talking about here is an x to the 0 power. And we know that anything raised to the 0 power is 1. So then that x would just basically go away. So an example would just be number 8, for example, or maybe number 7, or -7, or a 1, or maybe a -2, or maybe even like 243. That would also be a constant. So notice all of these numbers here, whether they're positive or negative, they all have no visible variable there, and that's because all of them would have had a variable x to the 0 power, which turned into 1 and is no longer there. So now when we talk about a degree of 1, this would be a linear polynomial, and that means that your x has a degree of 1, which we don't typically write that one. It's implied when we don't see it there. Now, it could be multiple terms, like this here is 2x plus 1. That would be linear, but 3x would also be a linear term, or -x minus 2 would be linear, or -4x would be linear. All of these would be linear. They may or may not have a constant adding or subtracting after the linear term, but you have, notice all of these have the largest x value. There's just a regular x with the exponent of 1, making it linear. Okay, so then the next one would be a degree of 2. So this is basically an x squared that we're looking for, and these are called quadratic. The quadratic term will have to have an x to the second power as its largest degree. So here's an example. There's 3 terms here, but the largest one is that x squared. Another example, you might just have negative 2x squared all by itself, but because it has a degree of 2, that would be quadratic. Or you might have something like x squared plus 7. There's 2 terms there, but the largest one has an x squared. Or you might have something like negative x squared plus 2x, for example. Again, there's multiple terms there, but the largest degree is the square, so that would make it quadratic. Okay, so then the next one we're going to look at is a degree of 3, which is an x cubed, and this is called cubic. So here's an example of a single cubic term, but cubic terms could also be added or subtracted to other lower degree terms. So we could have like 2x cubed minus x squared. That would still be cubic because the larger exponent there is the cube. Or you might have x cubed plus x squared minus 1. That could be cubic because the largest exponent there is that cube, and so forth. All right, and then we have a degree of 4, and that is called quartic. And so any number of terms, as long as the largest term in the group is x to the 4th power. So here we have 3 terms, but x to the 4th is the largest degree there. You could just have something like negative x to the 4th plus x squared. Again, the larger exponent is the 4th power. You could just have a single term with the 4th power, like 2x squared, or anything like that. But in all of them, the largest exponent is the 4th power. Now, as far as remembering these different terms, cubic is pretty common or easier to remember for most people because most people know like a cube with 3, length, the width, and the height. Or it's a 3-dimensional figure, so 3. Constant is just a typical number. We don't see any variable attached to it. And linear looks kind of familiar because we finished graphing slope-intercept equations and things like that, which were all linear. Okay, but quadratic and quartic can sometimes get confused because people refer to both of those prefixes as meaning 4, so then people kind of interchange them by accident. So the way I think about it is the word quart, Q-U-A-R-T, right, means 4. So quart means 4. And I think about this 4 quarts in a gallon. So you're talking about milk, for example, or 4 quarters in $1, or 4 quarters in like a football game or something like that. So quart essentially means 4. Now with quad, sometimes people think of quad as meaning 4 as well. However, I just think about the muscles in my legs, right? I have 2 quadriceps, my left and my right. So I'm just thinking of that as a 2. So I don't know if that will help you remember the difference between those, but if not, come up with your own example that will help you. Okay, so now we're going to go on to classifying by the number of terms. Okay, so we had a whole bunch of different nomials over here. We have monomials and binomials and trinomials and polynomials over here in this, all these examples with the different degrees. So they can have a different degree and a different type of nomial, and I call it that because they're all going to end in that. So number of terms is how many terms are being linked together by addition and subtraction signs. So a polynomial with only one term is called a monomial. Now, all of these are going to end with this nomial portion here, but this is a monomial, and monomial means 1. So if you think about someone who's monotheistic, they believe in one God, or if you go to Disney World and you ride the monorail, there's one rail there. And notice that there's nothing being added or subtracted to this term. Now, as far as the degree, there can be many different monomials with all different degrees. So this would be a linear monomial. I could have a quadratic monomial if I write x squared, or I could have negative 2x cube, making that a cubic monomial, or I could just have the number 7, making it a constant monomial. So there's all types of degrees within monomials. Now when we go to 2 terms, this is called a binomial. And if you think about this prefix here, bi, you see it with bifocals, which are glasses that allow you to have 2 different prescriptions in them, or a bicycle has 2 wheels, or sometimes you'll hear something, a biannual sale means twice a year. So the prefix bi indicates 2, and so you'll look at it and there'll be 2 things, 2 terms being added or subtracted. So here we have 2x plus 1. You might see something like x squared minus x. That would also be a binomial term. X cubed plus 4 would be a binomial term. Now again, notice the degrees may all vary, but there's 2 terms being added or subtracted, which makes it the binomial. Okay, then the next one we're going to do is going to be 3 terms, and that is going to be a trinomial. So I kind of think of that one. It reminds me of triangle, which is a shape with 3 sides or 3 angles, or triathlon is an event where you're doing 3 different sports. A tripod to hold your camera would have 3 legs. So again, there's 3 different pieces here with the addition and subtraction signs kind of linking them together. So I have 3x squared plus 2x minus 1 is one example. Another example might be x cubed plus x squared minus x. That could be another example of a trinomial. And then finally, when we talk about polynomials, poly means many. So at this point, anything more than 3, we're just going to kind of group them all together, calling them all polynomials. And poly means many. So if you were polytheistic, you would believe in many gods, let's say. That would be an example. Or a polygon in geometry is a many-sided figure. So poly means many. So once we get to 4 or more, we're just going to group it all together as this polynomial. All right, so we're going to refer to this chart here to classify some of these other things. All right, so classifying by degree is from the first chart we went over. Classifying by number of terms would be the second chart that we just went over. Okay, so let's take a look here. So for this first one, this is simply just, there's no x there, right? We don't see it. So that really means the x was to the 0 power, which would make this a constant. So the first thing you want to do is look for an exponent. That tells you the degree. After that, you want to see, well, how many things were added or subtracted together? And that tells you the number of terms. Well, there's nothing adding or subtracting to this -3, so therefore it'd be a monomial. Now, there's one other piece I want to add in here, and that's that lead coefficient. Okay, I mentioned it in the beginning of the notes. So the lead coefficient, as long as your example is in standard form, the lead coefficient would be that first number in front of your variable. In this case, my variable is x to the 0, so we don't even see it. So my lead coefficient here would just be -3. So let's take a look at the next example. So the next example here is a 2-term, right? So we know this is going to be a binomial because there's 2 terms there. But the exponent would really be x to the first power. And that first power is called linear. So this would be a linear binomial, and the lead coefficient here would be -1 because in front of this x I have a negative, which means it's really a -1. Okay, the next example is also a binomial again because there's 2 terms being added together. But the first term here this time has a square on it, which is the exponent of 2, and that is known as quadratic. And the lead coefficient here, you don't see a number there, so then we know it's just 1. Okay, then this next one, we have 1, 2, 3, 4 terms being added or subtracted. So that is just going to be called a polynomial. We're not going to give it a special name. And the highest exponent is this 3, which is referred to as cubic. And since that's my lead term there, my lead coefficient would be 5. And then finally, my last one, I have 3 pieces here being linked together. So this would be a trinomial. My lead term is the one with the highest exponent, so this negative x to the 4th, which makes this a quartic since it's 4th degree, and my lead coefficient would be the negative 1 out in front. All right, so now we're going to go over adding and subtracting these polynomials, and then we're going to continue to classify the answers just so that we can get a really good, solid understanding of those classifications. So when I add polynomials, you have to combine like terms. You want to combine your like terms. And so in order to avoid missing out things or combining wrong things, I like to kind of line them up, stacking on top of each other the like terms, and making sure that they're in standard form as well. So I'm going to look at my first polynomial here, which happens to be a trinomial, and I see that it's already in standard form because it's already going x squared, followed by my x term, followed by my constant. So that's good. So now when I go to look at my second piece here, I'm just going to stack them underneath. So I'm going to add the 3x. So I'm going to add that to my other x term, which would be here in the middle. Then I'm adding this negative 4x squared, which really is just like subtracting. So I'm going to stack that under my other x squared. And then I'm going to add this 2. So I'm going to put that here under my other constant term. Once I do that, I'm just combining the like terms, and they're already organized for me in columns, so I don't have to worry about missing any. So 2x squared minus 4x squared, I'm just going to take care of those coefficients. So 2 minus 4 is negative 2, and it will still be an x squared. Then I have my x plus 3x, which is really like a 1 plus a 3, so that's going to give me 4x. And then negative 8 plus 2 will give me negative 6. So this is going to be my sum. And then I want to classify this. And I'm going to classify it according to the degree, which is 2, right? So this is a quadratic. And then there's 1, 2, 3 terms here. So that will be a quadratic trinomial. Okay, so looking at the next example. Okay, I already have 4x squared minus 7, but there's no x term there. So I'm just going to rewrite it and leave a little space so that if I have an x term, I know that it's going to go in the middle. Now I'm going to add 6x. You see what I mean? That wouldn't line up with either of those. And then plus 9. So now I'm going to combine my like terms. So I have 4x squared and plus 6x, and then the negative 7 and the 9 will combine to get me a positive 2. Again, I'm going to classify this. My highest degree here is that second degree, which makes it quadratic. And then there's 1, 2, 3 terms, which again is a trinomial. All right, so then let's move on to the next one. Okay, so next one, I look at my first polynomial here. I have 5x squared minus 2x plus 4, which is already in standard form. So now when I go to add my negative 2x squared, I'm just going to line that up underneath my other x squared. Then I'm adding 3x. So I'm going to line that up over my other x term. And then I'm adding negative 1. So I'm lining that up there as well. So now 5x squared minus 2x squared gives me 3x squared. Negative 2 plus 3 is positive 1x, and 4 minus 1 is 3. And this, of course, again, highest exponent I see is this 2, so this would be quadratic for the degree. And there are 1, 2, 3 terms here being added or subtracted together, so it is a trinomial, so quadratic trinomial. Okay, next one, my first piece here is already in standard form. I have an x squared followed by an x followed by a constant. So I'm going to add the x, lining that up underneath the other like term there, subtracting the 3, and now I can combine my like terms. So I have an x squared plus 3x minus 2. Again, classifying by degree, my highest exponent here is the 2, which is quadratic. And I have 3 terms here being added or subtracted together. So again, it's a trinomial. All right, so taking a look at number 5. 4x squared minus 7x plus 2 is already set up for us in standard form. So I'm going to subtract the x squared, add the x, and subtract the 2. Now 4x squared minus 1x squared gives me 3x squared. Negative 7 plus x is negative 6x. And then these 2's are going to cancel. Now in this case, I still have quadratic because my degree, my highest degree there is that exponent of 2. But this time it'll be a binomial because I only have 2 terms here with the subtraction sign in the middle. Okay, let's take a look at number 6. Now this time, my first 2 terms are in standard form. I have my y squared followed by my y. So now when I want to add my 5, I'm actually going to leave it there because these 3 would just be y squared, then y, then a constant. But my minus 15y, I'm going to line up underneath my other y term. Then I have adding the y squared. So I'm going to add that over here. Then I'm adding 24, so I'm going to add that underneath my 5. And then I'm subtracting this 17y squared. So with the y squares, I have a 7 and a 1, which gives me 8. And then 8 minus 17 will give me a negative 9 squared. Then 15y minus 15y cancel out. And then 5 plus 24 gives me 29. Quadratic again, because my highest exponent here is a 2, but it's only a binomial because there are only 2 terms there being added or subtracted together. All right, so the last thing we're going to do is do some subtraction. Now, subtraction is going to be very similar to what we just did. You just have to make sure that the subtraction sign is getting distributed to everything in the parentheses that follow it. But because we're going to stack them up underneath, we can kind of do that as we rewrite that. So the first part, again, same thing on the last page. It's in standard form. I have 3x squared plus 2x minus 6. That looks good to go. But now I'm going to subtract this x squared here. So I have to make sure when I line it up over here, I'm writing minus x squared. And if you want to put the 1 there, you can. But now I'm subtracting this 2x. So don't write plus 2x here. You have to write minus 2x. And then I'm subtracting this 3. So again, I'm going to write minus 3. So if you do that, when you rewrite it and stack it up and put the like terms together, then it's the same thing we just did on the other page. So 3x squared minus 1x squared will give me 2x squared. 2x minus 2x will cancel. And then negative 6 and negative 3 give me negative 9. And of course, this will be a quadratic binomial. Okay, so we go to look at the next one. The first part is exactly the same. It's 3x squared plus 2x minus 6. I'm going to subtract 2x. I'm lining that up in the middle under the other x term. Subtracting x squared, putting that under the other x squared term. And then subtracting the 3. Okay, so 3 minus 1 is 2x squared. The 2x's cancel, and then minus 9. It actually ended up being the same answer as the last problem, which would also be quadratic binomial. Okay, so going on to number 3. So here my first polynomial is in standard form because I have p squared followed by a p term followed by my constant. So I'm subtracting 2p squared. So that's going to go under my other p squared. Then I'm subtracting negative 5p, which really means I'm adding a 5p. So I'm going to put that under my other p. And then I'm subtracting a 1. So notice again, as I distributed that negative to everything, I put what I ended up with underneath the other like terms. So 6p squared minus 2p squared will be 4p squared. 4p plus 5p will be 9p. And then 5 minus 1 is 4. Okay, and then this is quadratic because the largest exponent there is that 2. And it's a trinomial. And quadratic trinomial. Okay, next one here. Now I have 9x plus 2, which is in standard form currently. I'm going to subtract a negative. So this can become a plus 3x squared. And when I go to line it up over here, I don't have a like term. So I'm going to actually put it over here to the left since it would come before the 9x. Then I'm subtracting a negative 5, which is going to make that a positive 5. So the 3x squared doesn't have anything to combine to. The 9x doesn't have anything to combine to. And the 2 and the 5 can add up to 7. But notice I put my answer in standard form. The x squared term came first, followed by the x term, followed by the constant. Again, my exponent here is going to make this quadratic because it's a 2. And it is a trinomial because there are the 3 terms there. Okay, number 5, I have a cube this time, followed by a square, followed by a constant. So it is in standard form. There's no single a term there, so we might want to keep that in mind. So sometimes in that situation, it's a good idea to write this and just leave a little space where there might be something. Now I'm going to subtract a cubed. So I'm lining that up under my other a cubed. Then I'm subtracting 3a squared, so lining that up under my other a squared. Then I'm subtracting a negative a, which is going to make that addition, and this is why I left that space, because that didn't have a like term in the first polynomial. And then subtracting the negative 4, which is going to make that adding 4. Now all my like terms are stacked up nicely in columns, so I have 3a cubed minus 1a cubed, which would be 2a cubed. Negative 4a squared minus 3a squared would be negative 7a squared. Then I have my little plus a, and then plus 7. Now this answer, because my highest degree was a third power or a cube, it's going to be a cubic. And then because I have 4 terms, 1, 2, 3, 4, it's just going to be called a polynomial. So this would be a cubic polynomial. All right, and then let's look at this one. Now this time we have 3 things being subtracted. So my first term here is x cubed minus 6x. And while it is in standard form, it doesn't have a squared, which would go in between those two. So I'm just going to leave a little space. So now I'm subtracting this 2x cubed here. I'm going to do this in a different color so you can kind of see the layers. So I'm going to line that up over here under this x cubed, and then I'm subtracting the 9, and I'm going to put that down here at the end where a constant would be. And then I'm going to subtract the 4x squared, which notice that's a squared, so that would go right here. And then I'm subtracting an x cubed. So they're really trying to trip us up on this one by mixing up kind of the order there. All right, so now with cubes, I have a 1x cubed minus a 2x cubed minus another 1x cubed. So these two really could just cancel each other out, leaving me with negative 2x cubed minus 4x squared minus 6x minus 9, because there were no other like terms. Again, this would be a cubic polynomial. Cubic because the largest degree is that third power, and polynomial because you have 4 terms being linked together with the addition and subtraction signs. All right, now we can do combinations of addition and subtraction. So if we look at this one here, we're adding together the first two, but then we're going to subtract the third one. So if you're going to continue with that stacking method that I've been kind of setting up, it's not going to be very difficult to do this. You're just going to have 3 layers. So the first one here, again, I have 3x squared plus 2x. That is already in standard form. Then I'm adding x squared. So in my next layer here, I'm adding that x squared, and then I'm adding the 3x. So they went nicely underneath. Now here I'm subtracting an x squared, and then I'm subtracting a negative 3x, which really means I'm adding. Okay, so now just combining those like terms. So here we have a 3 plus a 1 minus a 1. These two are going to cancel out, leaving me with just that 3x squared. And then 2 plus 3 will give me an 8x there. And this, of course, would be quadratic. And then it would be a binomial because there are only 2 terms there being linked together. All right, now with this last problem here, I want to make sure that I have to distribute this 2 first. So 2 times negative x squared would be negative 2x squared, and 2 times 2x is going to be positive 4x. Now when I go to the next polynomial here, I have a negative, so I'm subtracting, which is really just distributing that negative first and then lining up all the like terms. So negative times the negative will make that a positive x squared. Negative times 3x will make that a minus 3x. And then minus the negative 1 will make that a positive 1. So you can see kind of how I lined those up. And then we have plus 2x. So lining that up underneath my other like terms. And then plus 4. And then you can kind of combine the like terms from there. So we know this first one, negative 2x squared plus 1x squared would give me just a negative x squared. Then these 3 can get combined because they're all just x's. So 4 minus 3, which is 1, and 1 plus 2, which is 3. And 1 plus 4, which is 5. And then that will be a quadratic trinomial.